Hello and welcome back to my show. Today, right on my left, I guess that's more of the right, I can't tell actually from this perspective, I'm going to show you these fun new curves I've been working on. This was part of a hackathon project we had last week at Fuse, where I work on the animation and layout engine. And what my project was this fancy little spinner here. And not really the spinner, but the technology behind the spinner. So we have a new feature. It has to do with the curve feature, and I would like to show you how I did that today and give you a little bit of background about it. And if you have any questions, then let's see what they are, and I'll tell you about what it takes to go from this step here to getting this into the actual product and where we are. First, I just want to close this. And let me run you through this demo a little bit first. This is the demo I created for our hackathon. And I'll just run you through the demo, explaining a little bit what's happening, and then go a little bit more into technology. This was my take on a loading screen. I'm sure, like you, I get kind of annoyed at loading screens are just something spinning in a circle. It happens quite a bit. It's actually something I don't like on the PlayStation as well. I just a little spinning icon. You don't see things actually moving. You're not sure if something's stuck or not when you see spinning. So this is my take on a different type of spinning. It shows that stuff's actually happening. And you'll notice the colors follow a path, and they have little lines, and they have additional lines. And this is actually some fairly simple Fuse code, and we'll get back to that later. Let's go to the next page, which was actually, this wasn't what I started on. I added this at the end. This inspired my project, but it's not the first thing I did. Well, after I got the tech working, this next page is actually the part of the demo I did first. And I just called it growing. And you just watch it go. Okay. And it's a fairly simple demo. And it was actually a bit easier to get working than the page before because it actually involves fewer curves. And it had a bit of timing I had to get right, and we'll get back to that later. This end a little bit about rocking back and forth. This actually demos another specific feature that the first page doesn't, and it has to do with dynamic curves. And I'll get back to that too, but basically this main thing here, this centerpiece is a dynamic curve as opposed to a static one. And what I wanted to show in the demo too was that this type of thing has practical benefits. It's not just for animation. Some of the requests for this actually came from our charting API. We wanted to show highlights and stuff on charts, and there wasn't really an easy way to do it before. And although this part of the API is not quite done in my demo, I just wanted to show a little bit about how helpful it can be. Now these lines in this screen are a bit weak, but there's a line coming down here. I can probably highlight that a little bit better if where's this thing here? I have this highlighting tool. So there's actually a line coming down here and a line coming down here. Alright, the first one is straighter. Just so you can see. Now what's important about these lines is to note they're attached to the graph at a specific point. Okay? Hopefully you can see those lines. And this allows you to attach effects to a graph because the graph data is obviously dynamic. It's not in this demo, but it could be. I just didn't make a button in time to modify it. And you'll be able to attach things to the top and bottom, pointing from specific places in the graph, which is often useful when trying to visualize data. Now I also highlighted a section of the line, and it's right here. And I just made some quick demos. Like we want to see if this were a graph of time. Well, what would the time be? Well, we have the 1.5 release, and post-release, well, it's going to refer to this time instead. So we highlight the section of time, it deals with post-release, and then maybe the warm-up time. So this can be useful for visualizing associations between events when you have different criteria of data and you need to highlight part of the line. And I'll get more to the details of this later, but this is to show the practical benefits of having partial line drawing beyond just plain animation, which is also fun, great for simple things and a lot of effects. There are practical benefits that goes well beyond graphing, but graphing was the one that I could come up quickly. Now, to make sure that nothing was too serious in this demo, though, I just added another one of the fun features, and this actually demos a feature as well. Let's just turn on the fun mode. And we can see our little roller coaster going up and down. Obviously this graph isn't perfect for roller coasters. But again, this is dynamic. This isn't some... If this was actually a graph, if you modified the graph values, the roller coaster would obviously follow the graph values. If it was an actual roller coaster, you wouldn't make the lines so tight. But this works, and that's about all we have there. So I'm going to turn that off now. And so this is how I ended my demo. My final page in the demo was simply this. I simply turn it on to demo. There's no new effect here. It's just another use of this basic effect. Okay, this is some fairly basic stuff. I mean, it's the exact same effects we saw from the previous page. It's just put to a different use. And so that's the basics of my demo. This is what I did for the hackathon. And now I'd like to get a little bit into the technology behind it. And I'll start a little bit at the top level here first. So not in the demo, I actually had on a final page here. And I have the code published for this. It's on my Git repository. I'll make sure I push up the newest version. And I had these types of graphs. I want to check what it was, and I can explain what the demo is. But let me go to the test curve. This is the curve I actually started with, except these end bits. The end bits I added on afterwards. And this feature has two components to it. Let me look at the test page. And these two components, let me see where they are in this file. If you look at this item right here, this path, the two components are now path start and path length. This was the feature that I added, and this is controlled by the sliders at the bottom. Again, I forgot to make this one for streaming, so the text might be a little bit small in this window here. And start is simply where this purple one says. Where along the path does my path start? Now, this path actually has two paths in it. If you look at my code, I have the partial path sitting on top of the gray background path. So you can see that the green part is part of the path highlighted, and the gray path is the entire path. And the stream start is simply where does my starting point go to? And the length is how much of the path I'm covering. And so obviously you increase that, it gets longer. And this was the basic feature that I wanted. And it's really I'd say from the user perspective, this is very simple. All we have is a path start. So we have this feature here and a path length, which is this one here. There is another way to specify this, one of the other demos. Instead of length, you can say end. The reason I have length is because length is often easier to animate, because if you have length, you can animate start and it moves the whole thing. Whereas if you have just end, you can animate length. I mean, they're just two different ways of looking at it. There's a third way as well, but I think these two cover it, length and end, and this demo here just does length and start. Now, let's look at a few of the features on here. Having these little dots at the front and the end, that may not seem so impressive, but you'll notice this path, it says nothing about this. I don't have any decorations. I had no feature to actually decorate paths. I mean, that would be way too specific if you started saying, all right, so there's an end cap, this end cap. So what I did instead is I added a function to it. Now, I'm not entirely happy with the function yet, the naming of it, but we'll look at it now. What is this for? The start point. I created a start point, and this is using a relatively new feature called let. Relatively new in that it's not actually released yet, I believe. No, this should be in the 1.5. The 1.5 view that came out, we should have let in it. And the new feature is this one, path point at distance. Let me put that on a new line so it's clear. So we have this path point at distance, and path is simply that path we have here. We have name path, and we say where, at what distance. And so it takes two parameters, which path and at what distance. And notice this distance is relative to the entire path. So the path start and path length on this curve itself do not influence this function at all. They're just there for the visuals. The path remains its full path, and if we say path point at distance start value, that means, okay, give me the point where the path is starting. And this happens to be based on the start value, and that happens to coincide with where we start drawing. If you look back at the graphing one, when we look at the points here for the graphs, these is using arbitrary points. So these would be arbitrary points in there instead. But for here, I'm just using it to show the beginning. And so when we have the start point, it's using let as the start point, and then we're going to draw a circle. And the circle bit is here, and this circle says where is it? X. Vector X is start point and start point. We're a little bit uncertain about the name vector X. We prefer to just say X, but we have a bit of a conflict now, and it's not trivial to fix, so we might be stuck with vector X for a while, but hopefully we can just get X working. But everything else about the circle is totally normal. It has a total normal width, it has a stroke color and a stroke width and a normal color, and it has an anchor. The anchor 50-50, you'll notice, is very common if you use, especially in my demos. When you have a specific point you want something centered on, this says, okay, the center of it is located at this X and Y. Otherwise, it would be the top left position there. And so what we have is that this is what gives us the purple circle, is that we had a circle and we just positioned it at the start point. And this makes it very useful because, like I say, there's no fixed decorations. You can stick whatever you want at the front of that curve. I mean, there's nothing, this is not an end cap. This is really an arbitrary element at the front of the curve. You can put it further in front of the curve, you can add a space, you can put it further in. Because this let expression is using an arbitrary value, you can put it anywhere, and that's exactly what the graph is doing. The graph is simply saying, well, give me a point from some random location on this graph, and it lets you draw things there. Now what we can point out in the second one, ignore the gray dot for a second, but look at the little arrow. This is at the end of the graph. You notice that as I move it, the arrow is actually pointing in the right direction. This requires a separate feature, because as you know, normally in layout everything has a fixed orientation, and to get this facing the right direction we have to know which way the curve is facing at that point. So to do that, I added a second option. So first off, I added an endpoint, which is just like start point, but it uses the end distance instead. And the end distance is, part value plus length dot value. Now this, I actually wrote this before I modified the properties. This could also simply be path dot end, and that should also work in some cases, but you're better off, since I'm using start value and end value, I added them together, and so I have an end point. And so this is the same, the circle, but now I have an image instead of a circle. I have the image, and the image is simply an arrow, but I add a rotation to it. You know, this rotation's a bit of a mouthful right now, and hopefully I can fix this by adding an edA angle, because we need an angle, and the angle is in radians. Fine, so we use a Euler angle, because for whatever reason I'm not exposing the rotations individually x, y, and z other than through Euler angle as radians. I just don't know why that is, but it's something I can fix. And the key function here is this one, path direction at distance. It looks much the same as path point at distance from up here. It takes a path and a property, and this one takes a path and a distance. And the difference is the direction. The direction is an angle. Well, it's actually not an angle, it's the vector. It's like which way is the vector pointing at this location. And a tan vector converts that to an angle. What I strongly suspect I'll do is I'll say path angle at direction, and this will greatly simplify it. And that'll give the exact same thing I had there, and even more. I might actually have angle z, and that would simply be this, and that'd be a lot reduced. And these are very simple changes from what I have now from the feature. And that basically tells it, well, basically it actually tells it how much do I rotate it based on which direction the path is facing at that point. And that's how we get the little arrow pointing the right way. That's also incidentally how on the roller coaster one, how the roller coaster is always facing the same way. It's following the path, it's slightly offset. And how this arrow, if you look at the arrowhead here, the arrowhead follows the path. This is also how it's following the path. It's using that same function, like where's my direction. This is not like a line arrowhead. This is an arbitrary graphic, and you can put whatever you want, and you use this function path direction at distance, or probably path angle at distance coming up, to say I want to orient something the same way the path is pointing, or I want to offset it, I want to point it a different direction. And this is one of the very useful things. This also shows some of the advantages of using expressions, and for using this new let syntax, relatively new, is that it lets you do a lot of these, I wouldn't say complex, but multiple step calculations strictly in UX. You don't have to resort to using JavaScript code to do this. You can stick directly in UX where it belongs. There's no round trip with Java. It's a pure animation thing. It doesn't touch your model state. You can do high-level animations with multiple steps without having to modify your actual business model. You can just do it completely all in UX and not worry about any round trip with Java or the variables. And so that was and the other last thing I did on this page is, it's using the same basic thing, is this little dot that follows the circle. It's always beside it. You notice it's always on one side, and it's always a fixed position right beside it, and it's also basically a variant of it. The alt point here, this is the circle again, and it has this alt point direction. Now here is okay, it has a direction, it has a point, so the alt point is directly on the pink one, wherever it is, and it's using the same distance as the end. I don't know why I did that. And the alt vec is the actual direction at that point. And here I'm not using the angle. Here I'll show you was the reason why I came with the distance instead of angle was because of this bit here. We have the end, oops, go past this here. Wherever the endpoint is, which is alt point, plus an offset based on the direction. And this direction is basically the point it's pointing, and if I did both of them plus, it would be right in front, but I did one minus. I flipped the y and the x, get a minus, which is essentially a 90-degree rotation, and that keeps it fixed away from a fixed distance from that point right there. Alright, if you have questions so far, please ask, and as always, you can ask later on Twitter as well. I tend to follow up. Now, this was the basic feature. So this was my test graphs, which is not so exciting. And what was important for the test is it has one line segment, a couple Bezier segments, and a line. But I needed to make sure this works with arcs as well. So my second line segment had SVG arcs in them. And it actually looks weird, this one. I mean, it works. And it's kind of weird following this path. You'll see the abrupt changes on the corners, because those are hard cusps. They're not smooth corners. It's not just because I'm moving fast, it's because those are actual hard corners in the source data. And then I also did the bloom, and this explains one of the other features that we have in this, is that when you're doing this, if you want to have a continuous animation, it's important you can smooth over that. So right now, I'm right at the start. So remember, the start point's up here, just some random location. And when I move the start around, the end goes smoothly over the start point until I'm back at the start. This is very important for looping animations, that you have to be able to bridge this starting point cleanly. And originally when I first built the feature, I would actually stop and say, look, you just stopped at this point. And instead now I just I broke the thing into two little segments, did the end and the start, and I guaranteed that you can go over that end segment. So your start can be any multiple of 1. It's just going to start at the modulus of that. And the length can actually also, the length is constrained though. You can't have a length greater than 1, but that makes sense because then your whole thing's filled. You can't have a negative length. But the start is allowed to be wherever, and it's allowed to overflow the end. By overflowing the end, it just makes it simpler to do animations. And we see that on the first page, the animation. these things smoothly go through the starting point. These 4 curves are nothing but, are all on the same path basically. So this is the loading animation. There's actually 8 curves here. And by path Celtic, it's a Celtic knot in the background. Let me show you that quickly. This is the knot. This is the actual shape that first page is following. They're a bit shorter, but if you can imagine, this is actually the path it's following. Goes up and down, and those are all the same path. So you have to move it slowly to see it here, and the precision is very high. But that's the actual knot that they're following. This is a typical Celtic knot, and you know, traced by me, of course, and that's the path that these paths here are following. And we have 4 of them for each color. And you'll also notice a short one comes out, and so we actually have 8 paths, and these are the 8 paths in this source file. The first 4 are the fat ones. They have a width of 15, and the next ones have the short width, which is 5. And that's the stroke width. The actual width is 40%. I should have made stroke width percentage as well, because that would be, it would be thicker than as you expand it, but that's also fine. And you notice it has a path start. I'll get to a second. It has something called BP progress, and this is kind of a cheating thing right now. What it is, I created this timeline called BP that loops, and I feel this was kind of a hack, but it actually works really well. This timeline does nothing, but it does nothing for 3 seconds. Now, as weird as that sounds, what it means is it takes 3 seconds for the progress to loop from 0 to 1, and then the play mode wrap says, all right, let's do it again, let's cycle through it. I think the cycle animator would actually be clear here, but timeline is actually very direct, and I actually have another feature I'm planning to actually make this easier, that this let syntax. Let will actually be variable as well. Right now it's read-only kind of, but if it was variable, then you could stick a cycle in. And I also have another pending feature about time generators, which basically just cleans up a little bit of this. Okay, but ignoring all that, we have a timeline. It goes from 0 to 1 over 3 seconds. If you want to count, that's how long it takes for this animation to loop, is 3 seconds. The green one gets back to the place where it started in 3 seconds. Okay, and I have 4 of them, and they're all on the same path. Okay, technically they're all unique path instances, but they have the same data. This is the path Celtic with the data, and that's the knot I showed you. And the path start is an expression. It's saying, okay, start at the timeline progress, and the second one is saying, well, start at the progress plus 0.25, and the third one plus 0.5, and the fourth one plus 0.75. This is what staggers them. Oops. This is what's staggering them 25% apart. And now this is actually an old feature I put in animating, is that when things used to wrap, like timelines, they used to get off sync. And there's only one timeline here, it can't get off sync, but if you use 3 timelines all of the same length, I've guaranteed that they'll stay in sync. I mean, this is a guarantee. And this combined with the ability for paths to go over the end. And you notice this progress, at some point it'll switch from 1 to 0, it'll jump. But because our path is allowed to shift over the end, you just don't notice that jump. It's continuously smooth visually. And whereas if you're actually doing it in one of the test paths, like my original test path, it was broken. So if you went over the end, which I can't actually do here, well, you can. If you go right to 1, you'll notice it jump back to 0. And so for broken paths, you'll notice that. You'll see as the broken path, the end jumps back to the start. Okay, now for the actual small lines, I couldn't decide. Honestly, the reason the small lines come up is because I wanted a second image here, but I couldn't decide what length looks good. And so I decided, well, let's just vary the length and see what happens. So these have the same path start. They're perfectly aligned. The red head is with the red head of the fat one. But they have different lengths. And this length is another let expression. This length it's a little bit more complex, the expression. And I wanted to vary, the reason I have this sign here is because I wanted to vary the length independently of the 3-second timeline. And you'll notice that here I have a second timeline for it, a BPL, which is duration 5. And the sign here, this is all just basically to get a cycle going. Again, I hope to clean this up with some special purpose things, but this is very general purpose right now. And it just varies the length of that long path. So the long path grows and shrinks in a sinusoidal fashion. And this is all these second curves do. They have the path start and path length, and they show what we can do with that. And that's basically that's basically new features. So it all comes down to a few new things: path start, path length, path end, and the other feature being path point at distance and path direction at distance. So this combination of very few properties lets us do all these wonderful new things. And so when we go to something like the flower, let me undo this again so we can look at it again. You can see the undoing also works, which is, you probably don't want to do, or maybe you do, but for this example it's not there. So let me just load the page, so growth page, and let's just watch it again as it grows. And you'll notice it's waving as it grows. So it's not a static path. The head of the flower and the 2 leaves are static, but the stem is not static. And that's where in the growth curve I actually use an actual curve. Curve are the dynamic curves in Fuse, and this creates a wobbling sort of stem to it. And I use that again with an offset, a timeline of duration 1, and I use this offset and I just modify the curve points, and it makes that dynamic curve. Now what's important to notice here is that the anchoring of the leaves and the heads actually follow the curve. It goes down slightly and up. And again, this wasn't to demonstrate any of my great animation skills. It was really to demonstrate that these anchoring principles are there, is that these other items are anchored to this main curve, and this main curve is dynamic, and that gives you lots of possibilities. And so that's right here. I have the 3 anchoring points, leaf, leaf, and head, and I actually use those in the leaf. So the path leaf, is again, there's this node down here. Let me get back to it just a second what those are. Path leaf, and it has a color and a width where it starts, and it also has a position. These positions are also going to become easier. The reason I have X and Y right now in these vector functions is because we're missing something called position. Ideally, I like to just say this. Right, that would be wonderful, and it's just a matter of just a bit of missing functionality. They have to do the long expression, but hey, at least the long expression works. And so that positions the leaf there, and this other one positions the leaf, and then there's a head of the stem somewhere, path flower at the top, which is also using the exact same code. Now the actual drawing of these, they all start at path length and path start at 0. And there's a while true here, which is attached to the switch at the top. So when the switch is on, this is a very standard Fuse animation. What happens when the switch is turned on? Well, the actual paths are change the stem path length 1, change it to 3.5, change the first path length to the leaf, this is the leaf, to 1, to 1, to 1, 1 being the full path and starting at 0. So that's what actually animates it. And when you unclick the switch, it goes backwards. As a typical animator in Fuse does, it goes backwards when you unclick it. And so going forward, you'll see that these have just delays on them. And there's an actual delay in the animator saying, well, when does this start? And it's those delays I use to time it, so that when the drawing gets the first leaf, it starts drawing it. When it gets the second leaf, it starts drawing it. And the head actually starts drawing slightly before, and it actually starts drawing slightly smaller, but it's really not an effect you can see, and so it can really be removed from the demo, but I left it in just because I wanted to see it work. Technically I wanted to make sure this was working. And then I'm changing the path of stroke as well, so the stroke of the stem actually gets a bit thicker, not very much. And that's the rest is just basic layout. There's not much more to this. And so it's very easy to do these things. A bit of a note about these paths. If you notice this path, not so friendly looking, and there's really no friendly way to do this. The data in this path, this is just plain SVG path data. You can open up your Inkscape or Illustrator, draw a path, and save it as SVG, and just copy this path out and stick it in there, and you'll get that path. This is how all these paths were imported. Ideally, at some point, we'll have a high-level tool doing this, and I know we have, like, our sketch importer does this, but it doesn't generate the code the same way. But the SVG was really meant as sort of a back-end, low-level support, but you can totally use it now for copying data in, putting it in these paths. You can hand construct them, or as we saw, you can also use curve. Curves don't need the main curve width because it's dynamic, and on the graphing page, the graphs also use curves, and they're also dynamic. So there's a couple options. You either copy and paste the SVG data, or you input the curve. And I might add more. I mean, the standard shapes like circle, ellipse, polygon stuff could all easily define a starting point and also allow the support of path length. Right now, it's only enabled at 2. Again, if you have any questions, just ask. This feature, I did it for the hackathon. The main feature took slightly over a day to finish, and that was with the prep work that I showed last time. I showed last time the tool about edA-qa and his way to split Beziers, and I had that tool prepared in advance, so that when I had to do the demo, I already knew what algorithm I did. But there was a lot more to it than that, and the biggest one was for length. When we have a curve like this, I mean, what does start actually mean? It's a value between 0 and 1, but like, what does that mean? Now, any reasonable person, I think, would say, well, it should be 10% of the distance. So if you have a start at 0.1, that should mean you start at 10% of the distance along the path. This creates an interesting dilemma, though, that, well, these are Bezier curves. It's not cheap to calculate the length of those, and it's even less cheap to figure out where along the length 10% is. But since this is mainly used for animation, it's a matter of, well, this has to go fast. So what I did is a very cheap approximation for now. Each of these curves are broken up a little bit. Well, not broken up. I just take the input curves and I take a very rough approximation of the distance and a rough guess about where that distance would be, and then place the point there. And for animation, it generally works. There will be situations where it's not quite accurate and you'll have to break the curve up more, but I plan on offering some options that automatically do that. And the other one is that at the expense of speed, I can actually do some pre-calculations that get this a lot closer. I mean, to get the animation, I think within 1 to 10%, 1% of this distance would be fine, and I think I can easily get that with a very cheap calculation, and I'm probably going to do that. And I already have other overhead I have to fix. But that's the feature there, and so it's distance-based. Length is also distance-based then. And because what you don't want is you don't want to be walking through the curves like if you had the bloom. These segments, these are both one segment, so this is one curve, or maybe 2, I can't remember, and this is one length of line. You don't want it taking just as long to move through the short line as it does the whole circle, so you want to have a relatively stable speed, right? You want it, regardless of where I am, you want the speed to be relatively stable. And again, it's just an estimate now. The estimate for the lines is exact because it knows exactly how the lines work, but the arcs are estimates. And I mean, the Bezier curves and the arcs are also estimated in that they're converted to Beziers and then just treated that way. I don't have special arc calculation now. And so for the knot, as you saw on the test page, I mean, there are speed variations here and you can probably spot them, but the destination is good enough. And if I make it just a tad bit more precise, it'll probably be good enough. But otherwise, I'll add an option saying which precision mode do you want to use. Do you want to use I can never offer exact. Exact would be crazy because the exact is actually quite expensive to do. If you want to say exactly 10% in this curve, well, I guess it depends on the curve, but it's actually there's no closed form, so I'd have to use an iterative method. This would have to be done repeatedly. So I'm just going to offer the estimates for now, on the assumption that, you know, everybody knows that it's an estimate. But for animations, it works just fine, even for graphs. For graphs is where I might offer the second mode, saying precise estimate, which will get it much closer to where it should be. But again, we're dealing mainly with mobile devices, and on such small screens, whether it's 1 or 2 pixels to the left or right, isn't going to change the interpretation of the data. Obviously, the person can see it, but they can't logically associate this point as being 60% or 61%. It's just too hard, so the estimate works all right. Alright, I think that's about all I have. If there's no questions, this feature, like I say, I did it last week. It's not necessarily a high priority for us to finish, but hopefully early in the new year I can have this feature in one of the pre-releases or in one of the releases, and you can play with it. What has to be done now is I have to add some more test cases for it. Obviously documentation, and I have to clean up that point at distance, or vector at distance, to be angle at distance, to get that working a bit cleaner. And I have another feature for let and a bunch of refactoring that has to be done beforehand. So I have 3 or 4 merges to do before I can even produce the pull request for this one. But once that's done, it shouldn't be too hard. It's a nice feature. It touches on one part of the system, but generally doesn't mess with things very much. So it's not a high cost system. And then hopefully we'll have curvy paths then. So let's start at the beginning again and see. Let's ungrow that, and I'll finish off with the demo. If you enjoy this and you like to see more, then please follow me. Please give your feedback on my channel or on Twitter, and do follow my channel so you can see more of my stuff. And obviously I'll follow up against what's released and some demos in the meantime. And for now I'm going to close it, and I'm going to end with this demo. I'll close this all again. Too much stuff. And my Christmas background is more fun than mountains, like on my default. So this is my loading screen. It's just done with the path start and path end feature. Very, very generic. Very simple to do now. And the growing is a demonstration of an animated curve with anchoring points on it, and a path start and a path end. And the extra bits inside are all path start and path end. And the practical example showing how it can be used for graphs, and to highlight the arrow moving through time, to highlight sections, connecting lines to points in the graphs, and of course just to have fun, the roller coaster on it, because who doesn't want a roller coaster on a graph? And this makes it really easy. Okay, and this is how I ended my demo. I just did my signature and text. So thank you for watching. Until next time, and again, please follow me and let me know if you have any questions or anything you'd like me to cover and fuse. This feature hopefully early next year should be released.